This is Pre-Algebra Lesson 2-9, Understanding Scientific Notation. In this lesson, you'll be able to use scientific notation to write very large or very small quantities. You will also convert numbers written in scientific notation to standard form in order to do that. And your language objective would be to explain how to use scientific notation to write very large or very small quantities. Okay. Very large and very small numbers can be estimated using scientific notation in order to make the numbers more convenient to use. Scientific notation also makes it easier to understand the magnitude of a number and compare it with other numbers. Let's look at solve and discuss it first. Scientists often write very large or very small numbers using exponents. How might a scientist write the number shown using exponents? We have this number on the board, 0.00003465398246998726485 ... right? That's a very small number. Scientists usually they oftentimes deal with very large or very small numbers, right? In chemistry, you may have very small numbers. And if you're talking about physics, you may have very large numbers. So think about how you can use your knowledge of powers of 10 to rewrite the number. How would you rewrite the number? Okay. You can round to the nearest 100,000 or 0.00003, right? 2.7 or 27 would be closer to 30, or 7 would be closer to 3 than 2, right? So you can write this estimate as 3 times 10 to the 5th power. Let's write that down. What if you round to a different decimal place? Okay, you can round it up to the first digit. Or what if you want to round up to the nearest 10 millionth? Okay, which would be 0.0000275. You can write as 275 times 10 to the negative 7. So another example, you can also say 0.0000275 could be written as, wait, 1, 2, 3, 4, 5, 6. 275 times 10 to the negative 7th power. Or if you want to write it as 2.75, you can do 10 to the negative 5th power. Okay. What does the exponent in 10 to the 15th power tell you about the value of the number? The exponent part. The exponent tells the magnitude of the number, right? How big your number is. It can also tell whether the value is greater or less than 1. All right, let's think about the question. What is scientific notation and why is it used? We will answer this in this lesson. Think about it throughout the lesson. All right, the next page, look at example 1. Writing large numbers in scientific notation. Louisa is searching the approximate distance between Earth and the Sun. Her father told her that the distance is 9.296 times 10 to the 7 miles. In an astronomy book, she found the following. Which distance is correct? Okay, we got 92,960,000 miles. Louisa's father used scientific notation to express the approximate distance because the distance is so great. Numbers in scientific notation have two factors, the decimal point and the power tens, right? The first factor is always a number greater than or equal to 1 and less than 10, okay? We want to keep it as one digit point, a decimal point, and then other digits, okay? And the second factor is always a power of 10. That is called the scientific notation. You can write the number in standard form in scientific notation and see if they are the same, okay? If you place the decimal point after the non-zero digits, after the 9, how many times do you need to multiply by to get the same number? Well, how many place values have you moved? 1, 2, 3, 4, 5, 6, 7, right? So count the number of digits after the decimal point to determine the power of 10, which is 7. The two numbers represent the same distance. So it's just a matter of a different notation, but they should still be the same. Let's look at this try question. The height of Angel Falls, the tallest waterfall in the world, is 3,212 feet. How do you write this number in scientific notation? Remember, you need to have the first factor to be a number greater than or equal to 1 and less than 10. You need to have only the 10th value of the digit and then a decimal point, okay? So move your decimal point from here until it's on the right of your first non-zero digit. So you have 3.212 times 10 to the, how many places did you move? 3. So you need to multiply 3 times 10 to the power 3, which is 1,000, to get about 3,000, right? That's how you can check. Convince me, why do very large numbers have positive exponents when written in scientific notations? And as we have seen before in the previous page, the smaller number have an exponent of negative numbers, right? The power has negative numbers. So why do big numbers have positive exponents and small numbers have negative exponents? Why? Because positive exponents represent positive powers of 10. Okay. The larger the number, the higher the power of 10. Okay, example 2. Write small numbers in scientific notation. What is the width of a red blood cell written in scientific notation? Now we're looking at a red blood cell. It's in your body, so it's going to be super tiny. Write the number as a product of two factors in scientific notation, okay? So we got 0.000000703. So how many zeros? 1, 2, 3, 4, 5. 5 zeros. So move your decimal point. 1, 2, 3, 4, 5, and 6 places to the right so that it has it's positioned on the right of your first non-zero digit. Okay, so you moved. Wait, did I count it wrong? Is it 6 digits only? 1, 2, 3, 4, 5, 6. Okay, I counted it wrong. It's 6-digit places. Okay, so you will say that's going to be power of -6 because your decimal point moved to the right. You need to multiply, you need to divide 7 by 100,000, right? A million. You need to divide 7 by a million in order to get this decimal place. So the width of the red blood cell expressed in scientific notation is 7.03 times 10 to the -6 powered meter. Let's try this question. A common mechanical pencil lead measures about 0.005 meter in diameter. How can you express this measurement using scientific notation? Okay, so move 1, 2, 3 to the right. Move your point 3 decimal places to the right so that you have 5.0 times 10 to the, how many times did you move? 1, 2, 3 places, right? To the third power. And that's going to be a negative because you move to the right, okay? It means you owe this 5 3 decimal places, okay? And don't forget your unit meter. Example 3. Convert scientific notation to standard form. Part A. Kelly uses a calculator to multiply large numbers. How can she write the number on her calculator screen in standard form? Okay, sometimes if you use a calculator, you may get this notation. There's an E. What does E represent? E represents 10 to the power of, okay? So 3.5, E15 means 3.5 times 10 to the 15th power. So how would you write that in a whole, like a full number, right? What's the standard form? The exponent is positive, so you're gonna move the decimal point to the right if you wanna multiply it out, right? So you can move it to the right 15 places. That's going to be a million, billion, trillion, and quadrillion. 3 quadrillion and 500 billion. Million, billion, trillion, right? Part B, how can Charlie write the number on the calculator screen in standard form? 8e -9. That means you have 8 times 10 to the -9th power. Okay, so you divide 8 with 10 9 times. So the exponent is negative, move the decimal point to the left. So you got 0.000000008. Okay, certain calculators may display scientific notation just like this, or it may use the symbol E or EE. Okay, the number that follows after that would be your power if your calculator is notated this way. Let's look at try question. Write the numbers in standard form. Multiply them out or divide them out. Move the decimal places by your power. So you're multiplying 9.225 by 10 18 times since the power is positive, right? So move your number 9.225 18 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, how many zeros do you need? Well, you had 3 non-zero digits. So if you subtract that from 18, you have 15. That is how many zeros left, right? So let's write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 zeros. You need to write all of them. There's no way to abbreviate this in standard form. It's such a big number. such a big number. Okay, so part A, you would have 9 quintillion, 225 quadrillion number. Yeah, that's a really, really big number. Part B, 6.3 times 10 to the negative 8th power. You would divide 10, right? 8 times. So you would move the decimal places to your left. 1, 2, 3, 4, 5, 6, 7, 8. Okay, but you go over 1 non-zero digit. So you have how many zeros? 7 zeros in between, right? So you have 0.0000000063. Make sure you have 2, 4, 6, 7 zeros. All right, let's summarize our lesson. Scientific notation is a way to write very large numbers or very small numbers. Scientists use scientific notation as a more efficient and convenient way of writing such numbers. A number in scientific notation is the product of 2 factors. The first factor must be greater than or equal to 1 and less than 10. The second factor is a power of 10. To write a number in scientific notation in standard form, you multiply the decimal by the power of 10. Okay. So today we learned about lesson 2-9, understanding scientific notation. You should be able to write really big numbers and really small numbers in scientific notation now. Thank you. That was lesson 2.9. I will see you in the next lesson. Bye.